Hi folks, today we will be discussing about field programmable gate array architecture and its application and what are all the different FPGA based technologies available. The first one is Sram, second one Antifuse, the third one flash based FPGA. First, an introduction about FPGA. So it is a technology where it has digital integrated circuit where it is configurable block of logic along with interconnects between these blocks. As we have discussed in the FPGA architecture in an array format, so we will be having many cells and each cell is called as configurable logic block and each has to be connected with the neighboring cell with the help of programmable interconnect. All the configurable logic block CLBs are programmable. The design engineer can configure such devices to perform a tremendous variety of tasks. Why do we prefer FPGA in electronic circuit? Because we don't want to use any breadboard or any soldering iron. We don't want to plug together any network interface modules. We don't want to have a chip produced at a factory. FPGA field programmable. So automatically we will be having a transistor to program. Gate, logic gates are present. Array, it is being in more numbers. So this configuration we call it as FPGA. So the topics in Unit 1, Introduction to FPGA. Unit 2, Design examples using programmable logic devices and finite state machines. Unit 3, Building block of FPGAs or CPLDs, complex programmable logic devices. Unit 4, Routing architectures. And Unit 5, Applications and case study. So in the first syllabus we have FPGA gate arrays, logic blocks, evaluation of programmable devices, FPGA design flow, applications of FPGA. And the last topic is technology mapping for FPGAs. The prescribed textbook, P.K. Chan and S. Maurat, Stephen M. Trimberger. So where the opportunity in this field programmable gate array have? First, the designation FPGA design engineer from e-info chips. They require people for experience in 5 to 8 years and they need the skills to be required in RTL design, register transfer level design, low power synthesis, low power design and UPF flow. So a candidate need to be good in Verilog and VHDL, application specific integrated circuit ASIC or FPGA in experience and RTL debug experience. And here the next position, senior FPGA design engineer for 3 to 8 years of experience. So they require top 10 semiconductor companies to test their next generation products and they need to know some protocols like I2C, inter-integrated circuit, SPI, serial peripheral interface. And the qualification is listed out. Next, every successful person has a painful story and every painful story has a successful ending. Accept the pain and get ready for success. With this quotation, let me move on to the next important topic in our syllabus, Introduction to IC. So here, integration circuit have different types. The first one, standard IC. In that we will be having MPU microprocessor unit, RAM, random access memory, op-amp, operational amplifier, ASSP, application specific signal protocol as coder or decoder, LAN IC, local area network integrated circuit, USART, universal synchronous asynchronous receiver transmitter. Last, ASIC, application specific integrated circuit are programmable IC, where we will be focusing on programmable logic device, programmable read-only memory PROM, programmable array logic PAL, PLA, programmable logic array, FPGA based field programmable gate array technology, fused anti-fused FPGA, memories, EEPROM, E-square PROM, OTP and flash, MCU microcontroller unit, EEPROM electrically erasable programmable memory, read-only memory is here, E-square PROM, EEPROM erasable programmable read-only memory, OTP one-time programmable, flash and mask. Semi-custom IC have gate arrays, channeled gate arrays, and C of gates gate arrays, and linear array. Custom IC, cell-based IC has standard cells or macro cells, and full custom IC. FPGA is a versatile and powerful technology. It enables engineers to create custom reconfigurable digital circuit as we wish. One can customize to perform a specific task, and it is an integrated circuit in which it has set of electronic circuits on a chip, both active and passive devices on a semiconductor material. And based on the applications of IC, we have different classification like standard IC, application specific standard product, and application specific integrated circuit as we seen the first introduction block diagram. An IC which is available from different manufacturers for a standard function is called a standard IC. Example, MUP microprocessor, RAM. An IC is for a specific use, and that we call it as ASIC, application specific IC. Example, laptop. And IC, application specific standard product, ASSP, is for implementing a specific function that appeals to a wide market. The example, encoding, decoding a chip, Ethernet. So FPGA, it have a series of CLBs which has been connected with the help of programmable interconnect. Programmable logic block, it consists of general logic, memory, and multiplayer blocks, which is bounded by a programmable routing fabric that allows blocks to be programmably interconnect. The two main important programming languages with respect to FPGA are Verilog and VHDL. There are different types of FPGAs based families. So static RAM, Antifuse, and then flash, which is nothing but EEPROM. Static RAM, static random access memory, which have a circuit in which logic gate, especially AND gate, and a flip flop, particularly SR flip flop. Set reset flip flop. It involves a small static RAM bit for each programming element. Writing the bit with a 0, it turns off a switch, while writing with a 1, it turns on a switch. Logically 1 if it is writing the bit, if it is writing a bit with 0, which is logically off. This is the most common programming technology by so far. Advantages, it is reprogrammable, it is a temporary one which we can customize or we can change the pattern as per the wish, and it is used to write on a normal SRAM. Disadvantage, it is volatile. Once the power off, automatically the data goes up. Okay, it erases, it corrupts the data once the power gets off. It consumes more power. We are going from Antifuse FPGA. It consists of a microscopic structure like a regular fuse that makes no connection. It can be programmed on both the sides of the antifuse. So we can see on both the sides metal 1 and metal 2. In between an insulator is present. Advantages, it is non-volatile. Once the power goes down immediately, so the data will remain as such. There is delay due to routing are very small, which has been considerable, and it requires low power when compared to SRAM based FPGA. Disadvantage, it is a very complex fabrication process and it needs an external programmer to program it. Next, we are moving to the last one, Flash FPGA, which is nothing but EEPROM. It combines the best both of first SRAM as well as Antifuse. Again, it is a reprogrammable and it uses a standard fabrication process. Advantages, it is a low power technology. It's secure like Antifuse. There is no theft or losing of data in a bit stream. Relatively faster. Disadvantage, though it is very fast, it cannot change in the future. So Flash FPG has a host PC where we will be develop the RTL coding over here with the help of user. And here is a board and a test where FPGA field programmable gate array. With the help of USB, the data in the format of digitized zeros and ones is being transferred. According to the coding, your FPGA board starts controlling the peripheral. Thank you.